Welcome students. Welcome to this video. In this video, I'm going to explain one important topic of ISC Computer Science syllabus. It is recursion. What are the points we'll cover in this topic? Let us go through that first. What is recursion? Then different categories of recursion. Then working principle of recursion. We'll give some examples, basically two examples I'll discuss in this video, factorial of a number and Fibonacci series. Then recursion versus iteration, how recursive function is advantageous or disadvantageous, and what is the basic difference between recursion and iteration. So, what is recursion? A recursion is a technique that allows us to break down a problem into one or more sub-problems that are similar in form to the original problem. What it means? It means given a problem, we have to get a solution. In recursive process, we break down this solution into smaller sub-problems or sub-modules, one after another, where one module calls another module of similar fashion and goes on calling. That is recursion. A function that follows this concept is a recursive function. Let us see an example of recursion. First, I am showing a non-recursive function, that is loop, and then we'll follow it with recursive function. Basically, any function which has loop within itself can be converted to a recursive function. So we all know about factorial. What is a factorial? It is a continuous multiplication of all the numbers from one number to that number. So if I take n as 5, it becomes 1 into 2 into 3 into 4 into 5. So when I'm working with the iterative part of this program or this function, here it is int fact int n. We have a variable int result. I've initialized it with 1 and starting the loop with 1 to n, I'm incrementing the value by 1, and inside the loop what I'm doing? Result equals to result into I. So when I is proceeding from 1, 2, 3, 4, 5, result will multiply the previous value with the new variable of I. Now let us see the recursive part of this function. In iterative function, what we have initialization, we have condition, we have reinitialization and the body. But in recursive function, you see the program is more compact and very few statements used. We use just basically if-else statement. So this is the function fact n. Now this n is actually the variable that is used for a loop part in iterative. We have the condition if n equals to 1 or n equals to 0 also, because 0's factorial is also 1. We are doing return 1. Otherwise, what it is returning n into fact of n minus 1. So here this fact is doing what? It is calling itself again. At the same time, it decreases or decrement the value of n for the next step. So when n is given 5, it will do 5 into fact of 4. Fact of 4 will do 4 into fact of 3, 3 into fact of 2, 2 into fact of 1, and so on. So this is the recursive part of the iterative concept. Now let us compare these two functions. In the iterative version, we are using two variables I and result, whereas in recursive function we are not using any local variable. Rather, we have one parameter variable n. In iterative version, we have three statements: initialization, condition, reinitialization, apart from the body. In a recursive function, we have only one statement, that is the recursive statement, which is constituted of the body itself. The iterative function must save the solution in an intermediate variable, but recursive function is calculating and returning the value in the single expression. I'll show this how it working on the board. Yes, students. So what is recursion? We have learned that recursion is a process in which one function calls itself within its body. That means, suppose I have a function, say any function f. Inside that function, we call the same function once again. So it will go on in the similar process. This is recursion. Now, if we see in this function, in this process, this is creating a loop within itself. Okay? So we can say that recursion is actually an alternative to iteration. That means any function where we are using iteration, that can be converted to a recursive function. Now we have to keep in mind two things or two factors when we are converting a function from iterative way to a recursive way. Let us see what is that. What is there in iterative part? When I have iterative part and its corresponding recursive part, in iterative part we have four components. Initialization of the loop, condition of the loop, that is where the loop ends, reinitialization, and finally the body of the loop. So in iterative part, we basically look into these four factors. Now when it comes to a recursive function has only two parts, base case and recursive case. What is base case? Base case is the statement that helps you to stop the recursion. If there is no base case in the function, then it will go on to an infinite recursion or an infinite loop. Like in iterative function, if your condition is always holds true, it becomes an infinite loop. Similarly, here in recursion, in absence of base case, it will become an infinite recursion. For example, in this function, if I consider we have certain statements, but there is no conditions. So statement 1, statement 2, statement 3, statement 4, calling the function again. So it will go on unless we have some base case. What is recursive case? Recursive case is the part where the recursion proceeds to the next step. Now, if here in iteration, what we use for loop, we use while loop, we use do while loop. But in recursion, we have if statement or if else statement or if else statement. So recursive functions used decision making concept in its function structure to implement the concept. We'll discuss this with some examples. Definition of recursion. Recursion is a powerful technique of writing a complicated algorithm in an easy way. According to this technique, a problem is defined in itself or in terms of itself. In implementing recursive technique in a programming, a function should be capable of calling itself. The function that calls itself again and again from inside the function body is called recursive function. So this is very important line. What is a recursive function? A function which calls itself again and again within its body is called a recursive function. In the recursive function, the calling function and the called function are the same. Now here one thing also you need to keep in mind. In a recursive function, when the function should stop calling itself, need to be kept in mind, and that should be the first statement. This statement we say as base case of the recursive function, and when the function call itself, that we call as a recursive statement of the function. Statement function call statement, fact equals to 4. So when I'm calling this function, so 4 will go here to n. So here I'm getting n equals to 4. So when n is getting value of 4, it will come over here. 4 is not equal to 0, so it will come to the else part. Now in the else part, what it will do here 4 into fact of 3. So it will do 4 into fact of 3. Now let us see what is the fact of 3. So again calling. So now what happens? N will get a value of 3. Here again 3 not equals to 0. It will come here. What fact of 3 will do? 3 into fact of 2. N will reach, get the value 2 now. 2 not equals to 0. It will come over here. So what happened? Let us see. Fact of 2. What fact of 2 is doing? Fact of 2 is doing 2 into fact of 1. So now n will get the value of 1. 1 still not equal to 0. So it will come here. So fact of 1 is doing what? 1 into fact of 0. Now n will get the value 0. When n will get the value 0, so what happened? Let us see in the fact of 0. Now fact of 0, when n fact of 0 will come, here what I'm getting? I'm getting the value as return 1. So fact of 0 will return 1. Now see here what's happening in this function. Fact of 4 is calling fact 3. Fact of 3 is calling fact 2. Fact 2 calling fact 1. Fact 1 calling fact 0. Now fact 0 finally will return 1. So this 1 will be returned to whom? This 1 will be returned to the function fact of 1, because fact of 1 has called fact of 0. So here what happened? We'll get 1 into 1. The value becomes 1. So finally, fact of 1 is getting a value 1. This 1 will be returned to fact of 2. So what fact of 2 will get? 2 into 1 is equals to 2. This 2 will be returned to fact of 3. So fact of 3 will get 3 into 2 equal to 6. This 6 will be returned to fact 4. So what fact 4 will do? 4 into 6, 24. Now finally this 24 will be passed where? This 24 will be passed to the value, to the variable p. So finally what we'll get? Finally we'll get the output printing p as 24. What is this one? 24 is nothing but 4's factorial, that is 1 into 2 into 3 into 4. So in this way the recursive function works. Now one thing here to notice, whenever a function is being called, it called the another function and in that way it is going down. In the return statement it will follow the similar path in back. Now this back movement we call in recursion as backtracking. Backtracking means the more it goes down till the end of the function unless it reaches the base case, and when it reaches the base case the return statement will return one after another until we get the first function, and then the first function will accumulate all the values and return the final result. So this is recursive process, and the flow of control in the function works in the similar way. Okay. Yes, students. Here is another example we are going to discuss about through recursion. It is Fibonacci numbers. We all know what is Fibonacci number. It is a number which is generated by addition of previous two numbers. So if we take a number like first number is 0 and 1, the next number is 0 plus 1 is 2, 1 plus 2 3, 2 plus 3 5, and so on. So what this function will do over here, I am taking the term, suppose this is the term 1, term 2, term 3, term 4 and term 5. Okay, so term 1 of a Fibonacci number I am taking 0, term 2 as 1, term 3 as 2, term 4 4 and term 5 I am getting the value 5. So I will pass the term value to the Fibo function and we will get generated one Fibonacci number for that particular term. Let me show an example over here. So I am start taking with the last number only 5. So what happened? I am passing the value of, let me show over here, Fibo of 5. So I have passed the function over here as 5. So here I am getting n value as 5. So what happened? 5 is neither 0 nor 1. So it will come to this part. Now what is here in this part? Fibo of 5 will call two functions. Fibo of 4 and Fibo of 3. Okay. Now Fibo of 4. So here I have to pass 1 time 4. So when I am passing 4, again it will call two functions. What it will do? Fibo of 4 will do Fibo of 3 plus Fibo of 2. So I am passing now 3. I am going with the left hand side of the number. Let me erase this one. Now Fibo of 3 is doing again two function calls. Fibo of 2 plus Fibo of 1. Now I am passing 2, again taking the left side. Now Fibo of 2 will do what? Fibo of 2 will do Fibo of 1 plus Fibo of 0. Okay, let me adjust the camera. Fibo of 1. So when I am passing 1, it will come over here. It will return. So what is it is doing? It is returning 1. So my left side is completed. Now with this left side, there is another right side function called Fibo of 0. So what happened? Now it will get the value of 0. It will return 0. This complete function will give you what? This complete function will give you a value of 1. So Fibo of 2 is getting a value 1. With Fibo of 2, I am getting Fibo of 1 again. So here what I am getting? Here I am getting 1 plus again Fibo of 1. So when I am getting Fibo of 1, 1 is returning again 1. I am getting 2 over here. So when I am getting 2, that means Fibo of 3 is getting the value 2. When Fibo of 3 is getting the value 2, what Fibo of 2 is getting? Fibo of 2 will give you the value, because we have seen over here Fibo of 2 is getting the value 1. I am just using this value over here, reusing it, or it can be again we can split it in functions to show it. Understood? So here I am getting value 3. So Fibo of 4 I am getting the value 3 plus. Now what is Fibo of 3 is giving? Fibo of 3 is giving you this value. Fibo of 3 function call, Fibo of function call calls these two functions. So these two functions return the value 1 plus 1. So this 2 I am adding over here. So Fibo of 3 is giving you 2, that means 5. So what I am getting? Fibo of 5, I am getting the value, what it will give? It will give you the value 5. So what is the fifth term in Fibonacci series? It is 5. Understood? This is a recursion where one function is calling more than one function. So one function calling two functions, this again call another two, and so on, and it will go on in that process. Earlier when you have seen the recursive function of factorial, that is an example of linear recursion, because here one function call exactly one another function, whereas Fibonacci series, it can be termed as a nonlinear or tree function, because one function calls two functions and then it gradually increases as we go to the lowest level in the function call. Now let us discuss the next point or next topic of the chapter, that is different categories. A recursive function can be categorized into the following categories. First one, depending upon whether the function calls itself or not, the recursion will be a direct recursion or indirect recursion. That means when a function calls itself within its body, it is direct recursion. When it does not call itself within the body, it is indirect recursion. Depending upon whether there are pending operations at each recursive call, the recursion will be a tail recursion or non-tail recursion. That means a function which has some executable statements pending while returning back the recursive statement or function call, those are tail recursion, and where there is no pending operation, we call that as a non-tail recursion. In this, the function factorial is a tail recursion. Next, depending upon the shape of the calling pattern, the recursive function will be a linear or tree recursion. A function call that makes in a linear sequence, that is one function is calling another, that one is calling another. So at each time there is only one function call, it is a linear function recursion. And when one function calls more than one function, so one calling two, two calling four, four functions calling 8, and so on, it is expanding, it becomes a tree recursion. Yes, students, till now I have shown you two functions in recursion, and in both the functions you have seen the function is returning some value. In that case it was integer. A recursive function can return any data type on which it is working or need to return. It may be int, float, double, string. But a recursive function can also be a void return type. Now there are two cases where a void return type recursive function is used. First one is when the function need to print the value within the recursive function, and another one is if the data type or the data member is the global data. It is mentioned as a instance variable in the global field, so it can directly work on those data, so it no need to return the value. So these are the two cases where a recursive function can be void. Here I am showing one example where I am using a print statement. Let me write it properly. Now over here, see what happened. I am taking a function even with a parameter. If n is equals to 0, I have a return statement. Now here a return is without any value. You can say there is no value in the return statement. You may ask a question, my return type of the function is void, then why I am using a return statement over here? Now you all have learned the concept of return statement in a function in class 10. Return has two uses. One is it return a value to the caller function at the immediate line statement, and another one is the return statement is used to exit the function there. Here a return without any statement will exit the function, and hence the recursion will stop. Now see over here, in this function, this is our recursive statement. Recursive statement. So I have a recursive statement first, and then we have a print statement. Let us see how this concept works. I've used a value as 10. Here the number I'm passing is the end value for printing the even number. I want to print all the even numbers from 2 to 10. So I'm passing the value 10. So what happened? It is going to even 10. Now when it is going to even 10, n is not equals to 0 here. Actually 10 is not equal to 0. So what it will go? It will directly go to even 8. See, now here one thing you have to keep it in mind. In the else part we have two statements. Statement 1 is a recursive statement. Statement 2 is your print statement. Now print statement is kept hold. It is kept in hold. So even 8 will do what? Even 8 will do even 6. Even 6 will call even 4. Even 4 will call even 2. Even 2 will call even 0. Now when I reach 0, what happened? We have only return statement. So immediately function will go back to even 2 function. Now even 2 function, that is even with the parameter 2, has one pending statement, print n. So what it will do? It will print the value 2. Next, after this, it will return the control back to even 4. So even 4 is left with its own value, that is printing 4. It will return to 6. So it will return 6 and it will print 6. It will return the control to the even with parameter 8. So it will print 8. And finally it will return to the function with the parameter 10 and it will print 10. So what happened? We got the even numbers from 2 to 10 printed. Clear? Now I'm showing one change in the function and see what happened. Okay. The change is nothing special, but these two statements I am just interchanging. That means earlier our first statement is the recursive function call. Second statement is the print statement call. Now my first statement is print statement. Second statement is the even, I'm doing -2, a recursive statement. So this is now our first statement. This is our second statement. Let us see how it works now. So I'm passing even 10. Okay, so when even 10 is passed, first it will print 10. So what happened? If this is, let me select the output box. Suppose this is your output box. Here it is your output box. So what happened? Even 10 will print 10. Then it will go to call even 8. It will come in even 8. What it will do? Even 8 will print even number 8 and it will call even 6. Even 6 will print 6 and then call even 4. Even 4 will print 4 and then call even 2. Even 2 will print 2 and then call even 0. Now what even 0 will do? Even 0 is simply returning the statement, so it will end the function and control back to here. Here no other statement left. So it will go for backtracking and the program ends. But the change is here what I'm getting and here what I'm getting. The change is here I'm getting the print as in ascending order. Here I'm getting the print in descending order. So if my statements are changed in the recursive function, the output changes accordingly. Hope you have understood all the three concepts: the factorial function, with a linear recursion, Fibonacci series with tree recursion, and a recursive function with a void return type. So this is direct recursion and indirect recursion. What is direct recursion? A function is directly recursive if it contains an explicit call to itself. So here in this example we are seeing the function foo is calling itself in the recursive part, and thus the control moves on within the function itself. What is indirect recursion? A function is said to be indirect recursive if it contains a call to another function, which calls the function itself. That means in this example we can see the function foo is calling function bar is calling function foo. So this is indirect recursion. Let's move on to the next part, that is tail recursion and non-tail recursion. What is tail recursion? If there is no pending operation to be performed on return from a recursive function call, then it is known as a tail recursion. And if there is any pending operation, then we say it as a non-tail recursion. Let us see in the example over here. The function fact is doing a return n into fact of n minus 1. That means in this part there is a multiplication pending till the function gets the value from its called function. So there is a pending operation, namely multiplication, to be performed on the return from each recursive call. So this is tail recursion. Now, this is non-tail recursion. Now, the next example, fact aux with two parameters, int n and int result. Now, in this function, see the return statement. In the return statement, the function is calling itself fact aux with n minus 1 comma n into result. So in this state, the return statement do not contain any pending operation. Rather, it is finalizing the multiplication within the function call itself. So thus, fact aux has no pending operation on return from the recursive call. In a tail recursion, what happens? The final value is being returned back to the called function in every recursive step. Let us move to the next one, linear recursion and tree recursion. What is a linear recursion? A recursive function is said to be linear recursion or recursive when no pending operations are involved. That means a function which is a tail recursion can be said as a linear recursion. More importantly, in a linear function recursion, the recursive statement proceed in a linear form. Now, what is tree recursion? A recursive function is said to be tree recursive or non-linear recursive when the pending operation does involve another function call. Now, let us see over here the Fibonacci example. In the Fibonacci example, I'm calling the recursive function more than once. So at every time when recursive Fibonacci function is called by 1, it will call simultaneously two Fibonacci recursive functions. So 1 to 2, 2 to 4, 4 to 8, 8 to 16, and it will proceed in a tree form. Now let us see the principle of recursion. Every recursive function consists of two parts, and those are very, very important parts. One is base case, Another one is a recursive case. Now what is base case? Base case is the step where the recursion comes to end. So a recursive function ends its recursive process through base case. If in any recursive function base case is not properly mentioned, the recursion may enter into an infinite recursive process. What is recursive case? In a recursive case, the function calls itself again and again, breaking it into smaller sub-cases. Let us see some examples. Factorial, calculating factorial using recursion. We have seen already this function in before. So in the factorial function, this one is the base case. When n equal to 0 or n equal to 1, I am doing return 1. That means when n reaches to 0, function will not further call itself, rather it stops the recursion. Otherwise, it goes on returning n into factorial of n minus 1. So in this case, the function will go on into the next step of recursion with next value. So let us see an example. When I'm passing factorial of 5, it is doing 5 into factorial of 4. So see, 5 is as a pending operation. Then factorial of 4 will do 4 into factorial of 3. Factorial of 3 will do 3 into factorial of 2. Factorial of 2 will do 2 into factorial of 1. 1 will do 1 into factorial of 0. Now factorial of 0 will return 1. So 1 into 1 into 2 into 3 into 4 into 5. Finally you will get the result 120. So this is a linear recursion. This is a non-tail recursion also. Let us see a Fibonacci series using recursion. In Fibonacci series recursion, we have two functions called in the recursive statement. So Fibo1 will call 2 functions, Fibo2 will call 4 functions, and so on. So see one example over here. When I'm passing Fibo of 5, Fibo of 5 is calling Fibo of 4 and Fibo of 3. Fibo of 4 will call 3, 2, 3 will call 2, 1, and so on, taking a shape of a tree. Let us move to the next. Deciding recursive algorithm. This is very important. When we have to write a recursive function, these points need to be kept in mind. Find the key step. Begin to ask yourself, how can this problem to be divided into parts, or how will the key step in the middle of the be done. Find the stopping rule or the base case. This stopping rule is usually the small special case that is trivial or easy to handle without recursion. Outline your algorithm, combining the stopping rule and the key step using an if statement. In recursive function, we use if statement, if else statement, if else if else statement. Check the termination, verify the recursion will terminate. Be sure your algorithm correctly handles the extreme cases, and then draw the recursive tree. Now move to the last part, that is recursion versus iteration. First of all, advantages of recursion. Recursion makes the program code compact and elegant. As it's used only if-else statement, it makes the program very simple, less number of steps. It simplifies the logic of the program also. Hence, the program is easier to understand, and it works well for computations which are larger in depth. Very important. There are certain programs which, without using recursion, may take pages and pages of programming code or program coding. Whereas using recursion, we can simplify those steps in few steps. Disadvantage of recursion. First of all, recursive function makes the program slow because of many function calls. One function is going to call another function, and in this process there are a lot of function calls involved that makes the program slow, because each time you call one function, that function goes on calling another and so on. It will come back in the same path by returning the control. Next one, it involves more memory consumption. If a function has one parameter in its list, and if the function is calling 10 times, in the memory 10 variables as a parameter will be executed or created and worked. If a recursive function is working on 2 parameters, then 10 function calls will result into 20 parameters or 20 memory locations. Thus, memory consumption is always more in recursive function. Next, if there is no proper base cases, the function may enter into an infinite loop or infinite recursion. Now, the last point, there are certain differences between iteration and recursion. First of all, recursive function, it is a partially defined as itself, whereas recursive function are loop based. So it is defined by itself, where we use if statement, else statement. In iterative function we use loops. Recursive function generally uses selection structure, that is if else. Iteration uses repetition structure or looping. Infinite recursion occurs with iteration. Infinite loop occurs with iteration, and in this case infinite recursion occurs. Iteration terminates when the loop condition or the condition comes to false. In recursion, when base case is recognized, then the recursive function comes to end. Further, recursion is a slower process. It takes more memory, but it makes program simpler and less number of coding. Hope you have understood this concept of recursion. Thank you, boys.